So this is the review key for Unit 5. So the first one is a review from the first unit. This is also going to be on the test. What we have to do is we're going to divide our polynomial by one of the factors. So we're going to take our factor here of x minus 1, set it equal to 0, and solve for x, which is going to be 1. That's the number that goes in our little box. And then we put the other numbers from the polynomial. We have 1 from x to the third, negative 8, negative 3, and positive 10. So we drop the first number, which is 1, times 1 from the little box gives us a 1 again. Minus 8 is going to give you negative 7, times positive 1, sorry, negative 7 again, which gives us negative 10 when we combine with negative 3, and negative 10 here, which gives us 0. Since we started with x to the third, and we divided by an x from the problem to the right, we have x squared minus 7x minus 10. And that is our answer. And the next question, we have a polynomial and its graph. We have to find all the different factors for that graph and the polynomial, same thing. All right, looking at the graph, we're given 2 out of the 3 different x-intercepts. We don't know this one. So we're going to use the 2 that we do know to synthetically divide the polynomial to find the third one that we don't know. So this is negative 1 and this is positive 4. So we're going to use both those numbers to synthetically divide the polynomial here. So we have 6, negative 28, 6, and 40. So we drop the first number, which is 6, times negative 1, which is negative 6. Negative 28 and negative 6 give us negative 34. Times negative 1 is positive 34. Plus 6 is 40. Times negative 1 is negative 40, which gives us 0. Okay, so that's the first step. Next, we're going to take our answer we just got and use 4 to divide it again to find the remaining factor that we don't know. So we're going to bring down the 6. Times 4 is 24. Minus 34 is negative 10. Times 4 is negative 40, which gives us 0. So we have 6x minus 10 as our remaining factor that we don't know. We have to also, though, write down the other 2 factors that we do know. Okay, so these 2 were answers. X equals negative 1, x equals 4. Now we have to revert them back to their factors. So we're going to make it x plus 1 and x minus 4. Now they've been reverted back to their factors, and these are the 3 factors that make up that polynomial and the graph. Same thing happening over to the next one. Okay, we're given a polynomial and a graph. We're given 3 points, but only 2 are known. This one we don't know. So this is negative 3, and this is positive 1. So we're going to do the same thing we just did. So we're going to put 1 here as the first one. It doesn't make a difference which one you pick, either 1 or negative 3 as the number in the little box. We're going to use them both, so the order doesn't make a difference. Negative 12, negative 38, 8, and 42. So drop the first number, which is negative 12, times 1, which is also negative 12. We're going to add those 2 things together to give us 50. Negative 50. Then we're going to get negative 50 again. Add them up, you're going to get negative 42. Multiply, you're going to get negative 42, which gives us 0. Now we're going to do this again, but this time with negative 3. Drop the first number, which is negative 12, times negative 3 is going to be positive 36. So negative 50 plus 36 is going to give you negative 14. Times 3, negative 3 rather, it's going to give you 42, which gives you 0. So again, this is our answer of the third factor we didn't know, negative 12 minus 4, sorry, negative 12x minus 14. And we're going to take our numbers here, these are the solutions, we're going to make them factors. So it's going to be x plus 3 and x minus 1. And these are the 3 factors that make up the polynomial and the graph. All right, next, These problems are always tricky on the test because there's two pieces to them, and everybody always forgets one of the two. Okay, you have to do two things. It has state the domain restrictions first, and then after you're done with that, solve each rational equation. So the domain restrictions are what the x's, or the p's in this case, in the denominator cannot be because it makes the graph or the equation, undefined. So we're going to take all of the denominators. We have p minus 2 equals 0. We have p plus 2 equals 0. And we have p minus 3 equals 0. I don't need to do the minus 2 again because it's already accounted for. So p cannot equal three things: 2, negative 2, and positive 3. These are the domain restrictions. This is its own separate standard or indicator on the test. All right, now we go to solving it. We've got to figure out what's missing. So we look at the denominators, and the first side denominator on the left side. What is it missing that the other side has? It's missing a p minus 3. We do the same thing to the right. What does the right have, or what is the right missing, that the left side has? It's missing a p plus 2. Okay. Now we can get rid of the bottom. We don't care about that. We're going to multiply the top. We have p minus 3 times the p minus 3 equals p plus 2 times p plus 2. Now we distribute. P times p is p squared. P times negative 3 is negative 3p. Negative 3 times p is negative 3p again. And negative 3 times negative 3 is positive 9. We multiply the other side. P times p is p squared. P times 2 is 2p. 2 times p is also 2p. And 2 times 2 is 4. Okay, we're going to combine the like terms first. I'm going to get p squared minus 6p plus 9 equals p squared plus 4p plus 4. And we need to solve for p, so we're going to take all the p's and put them on the left. I'm going to take all the numbers, put them on the right. So this goes away. All right, what will happen here is the p squared and minus p squared will cancel each other out. Negative 6 minus 4 is negative 10p. On the other side, 4 minus 9 is going to be negative 5. And now I just solve. I divide both sides by negative 10, and p will equal positive 1/2. Since that's not one of our domain restrictions from the beginning, that works as an answer. Now we do number 5. In number 5, the first thing we have to do is factor these. In number 4, they were already factored for us, so it was a little bit less work. Now we have to factor these. So we have to factor the denominators. So two numbers that multiply to be 15 but add up to be 2. Sorry, let me rephrase that. Two numbers that multiply to be negative 15 but add up to be positive 2. Be positive 5 and negative 3. On the other side, x squared minus 25 is the difference of two squares. So two numbers that multiply to be negative 25 and add up to be 0 are positive 5 and negative 5. So again, like the last problem, we have to find the domain restrictions first. So we're going to take the factors of the denominator, x plus 5, set it equal to 0, x minus 3, and x minus 5. These are the three separate denominators we have. We're going to solve them all for x. So x cannot equal these numbers. So it'll be negative 5, positive 3, and positive 5. Those are the domain restrictions. So if we get an answer after we solve this, it's one of those three numbers that doesn't work. All right, now we're looking at what's missing. So we have x plus 5 and x minus 3 on the left. It is missing an x minus 5 from the right side. On the other side, we have x plus 5 and x minus 5. It is missing an x minus 3. Now we're done with that. We can get rid of the bottoms. So we have 3 times x minus 5, and that equals 2 times x minus 3. We distribute. So we get 3x minus 15 equals 2x minus 6. All right, I'm going to subtract the 2x from both sides and add the 15. So 3x minus 2x is 1x, and negative 6 plus 15 is positive 9. And since that is not one of our domain restrictions, that works as an answer. Number 6. Now, although these numbers for n and 17 don't have denominators in them, they do. It's just not written because it don't need them. But we're going to put down 1 underneath each. Okay. Now, the only variable we have in the denominators of our fractions is n. So n cannot equal 0. So that's our domain restriction. That's done. Okay. Next, we're figuring out what's missing. So we have 3 different terms in here. The first term here has 1 in the denominator. What it is missing is an n. The second term has an n in the denominator. That's all you need. You can multiply the top by 1, but it's unnecessary. And lastly, our third term is missing in the n. So we need to have an n on the top. So now we don't need the bottoms. So we have n times n is n squared. Plus 16 doesn't get multiplied by anything. And 17 times n is 17n. To solve this, we're going to bring the 17 to the other side by subtraction. So we have n squared minus 17n, that's the next, plus 16, and that equals 0. So now we can factor this. What two numbers multiply to be 16 but add up to be negative 17? That would be negative 16 and negative 1. Now we take both of our factors, set them equal to 0, and solve. So we have n minus 16 equals 0, n minus 1 equals 0, and n will equal 16 or 1. And since that is not one of our domain restrictions, those both will be okay. Number 7. Again, kind of like number 5, we have to factor this first. C minus 4, that's found in the first and the last fractions here, are both difference of 2 squares. All right, two numbers that multiply to be negative 4 but add up to be 0 would be C plus 2 and C minus 2. It's the same thing. So we have to do our domain restrictions. So these are the values we're going to use. So C plus 2 equals 0, and then C minus 2 equals 0. So C cannot equal 2 or negative 2. Again, make sure you don't do the domain restrictions for your rational equations. Now, we're going to figure out what's missing. On the first fraction, we have C plus 2 and C minus 2. Well, everything else already has C plus 2 and C minus 2. That's not missing anything. And the middle fraction, we only have C plus 2, so we are missing a C minus 2. And in the third fraction, we have C2 and C minus 2, C plus 2 and C minus 2, rather. It is not missing anything, so there's nothing that's got to be multiplied to the top. Since that's all we're missing is something in the middle, we can get rid of the bottoms. We have 1 plus 1 times C minus 2 equals 3. So this is our equation. If I distribute the 1, which is kind of simple, we have C minus 2 equals 3. I'm going to get all the numbers to the other side, so I'm going to subtract 1 and add 2. So C will equal 3 minus 1 is 2, plus 2, it gives me 4. Well, since that's not one of my domain restrictions, that works as an answer. All right, moving on to some transformations of graphs. So we have the graph f of x equals 1 over x. We want to know how it's transformed with these pieces that were added or subtracted. So there's two transformations. There is the minus 5 inside and the plus 8 on the outside. All right. So the minus 5 makes the graph go to the right by 5. All right, it's inside the function, so it goes left or right, and goes the opposite of the sign. The plus 8 makes it go up by 8. It's on the outside of the function, so it goes up or down, and it follows the sign. That's really all I care about. If you can do that, we're good. Number 9. This has 3 transformations. It has the 2 on the top, 7 on the bottom, and the negative 4. All right, the 2 on the top is a vertical stretch by 2. The 7 on the bottom is a going to the left by 7. And the -4 is going down by 4. That's it. Now, these have been causing some problems, and we're making it harder than it has to be. This is the graph that you're given is the graph for 1 over x. This graph right here, that equation. So that means it's asymptotes are on the x and the y-axis right here. Okay, so what we're doing is we're moving them based on our transformation here. So these two things are making the graph move. Okay, and what they're really moving is the asymptotes, because the graphs are bounded by the asymptotes. So our graph's going to go to the left by 2 and down by 1. So what we're going to do is, if the graph goes to the left by 2, that it's going to change your vertical asymptote. So your vertical asymptote is now going to be in orange, 2 to the left. So now it's going to be here. And your vertical asymptote is going to go down by 1, so it's going to be right here. So I'm going to erase the red lines. Okay, so now we can put our graph back to be bounded by the asymptotes. Okay. Now we can use our method using algebra to find the y-intercept. To find a y-intercept given that equation, we're going to put 0 in for the x value and then solve. So this becomes 1/2 minus 1. If we make this into a fraction over 1 and multiply it by 2 on both the top and the bottom, we have 1 minus 2 over 2, or sorry, 1 over 2 minus 2 over 2, which gives you negative 1/2. We're going to write this as a point because it's a y-intercept, so 0 comma negative 1/2. This makes sense because the graph you can see right here is going through about negative 1/2 on the y-axis. Okay. Here, again, I'm going to draw in the asymptotes and show you how they get transformed using the equation. So again, their graph that we're using to start with is 1 over x. Those are its asymptotes. So now we're going to move them using these two numbers. So it's going to go to the right by 3. It's going to go up by 2. So the right by 3 changes the vertical asymptote to go to the right by 3. So now it's at 3. And then it's going to go up by 2 to make the horizontal asymptote go up 2. So I'm going to erase the red lines now. So I can do the graph, the sketch of the graph, just using the asymptotes as my boundaries without having to do too much other work. So that's what the graph will look like. Okay. Now, I know the way this is set up for A, B, C, and D and domain range, vertical asymptotes, horizontal asymptotes. I don't like that order. It's not the order we did in class because I think it makes more sense to do some of the other things first. Now you can do the vertical and horizontal asymptotes based on the transformations you did on the graph, or you can use it algebraically like we did before. It doesn't make a difference. It's the same thing. You should get the same answer. If you don't, then you're doing something wrong. Okay, for the vertical asymptote, just as a reminder, you take the denominator of your fraction, which is x minus 3, set it equal to 0, and solve for x. That makes sense because our vertical asymptote, when you look at the graph, is at 3. Horizontal asymptote, you put 1, and then you put a really big number in for the x, plus 2, which makes this go away, So y is equal to 2 for your horizontal asymptote, which makes sense because that's where it is on your graph. So same thing. Now domain and range. Domain is associated with the vertical asymptote. So we have negative infinity to 3, 3 to positive infinity. Your range is associated with your horizontal asymptotes. So you have negative infinity to 2, and 2 to positive infinity. And there you go. That's it. Okay. In this case, we want to rewrite a new equation given some information. So we wanted to go translate up by 3 and to the left by 4. If it's up by 3, it's on the outside of the function. To the left by 4, it's on the inside of the function. So we have g of x is equal to 1 on the top. And then you have x. So now left by 4 is inside the function. So left by 4 means you have to add 4. And up by 3 means you have to add 3 on the outside. That is the new function. Okay. Now, what we're going to do is, again, we're going to use the graph and our transformations and equation to help us. So our asymptotes are normally here on the x and the y-axis. So we can look at the original problem. It says up by 3. So we're going to take the horizontal asymptote and move it up by 3. So now it's going to be here. The vertical asymptote is going to be moved to the left by 4. So 4 is right here. Let's erase the red. We can now make our graph. Right here. Right there. So the graph is being bounded by the asymptotes, and it's just kind of a quick sketch. Okay. Again, I know this is in a certain order. I don't necessarily like this order. I like the order we put it in when we did these problems in class. So that's what I'm going to do. I'm going to go back and change the order. Do the y-intercept first. So I have 1 over 0 plus 4 plus 3 on the outside. This becomes 1/4 plus 3. I'm going to make this have 3 have a denominator of 1. I'm going to multiply both the top and the bottom by the denominator of the other fraction, which is 4. So I get 1 over 4 plus 12 over 4. And now I can combine those two terms. I get 13 over 4. So my y-intercept is 0, 13 over 4. Okay. Vertical asymptote, I take the denominator of my fraction, x plus 4 equals 0, and solve for x. Horizontal asymptote, I put a really big number in for the x value, which gives me that being gone because it's basically 0. So I got y equals 3, which is whatever's left. Let's box this one. There we go. All right, your domain is related to your vertical asymptote. So I have from negative infinity to negative 4, and negative 4 to positive infinity. Your range is related to your horizontal asymptote, negative infinity to 3, and 3 to positive infinity. And there we go. Again, what are the transformations? We have 2 transformations. We have the minus 4, which means it's going to go right by 4. We have plus 2, which means it's going to go up by 2. I'm good with that. Again, we have our graph. I'm going to make it the same thing. So our asymptotes are here on the x and y axis to start with. And we're looking for how they were transformed. So we're moving the vertical asymptote by 4 to the right, so it's going to be right here. And the horizontal asymptote up by 2. Erase the red. Okay. Now I can draw in my graph. Just doing kind of a sketch, so it doesn't have to be entirely perfect, but it's going to be somewhat close. All right, then let's do the pieces here. So your y-intercept, again, you're going to put 0 in for the x term. So we have 1 over 0 minus 4 plus 2, which gives me negative 1/4 plus 2 over 1, multiplied by the denominator of the other fraction, which gives me negative 1/4 plus 8 over 4. Combine those two numbers at the top now, which gives me 7 over 4. So my y-intercept is 0, 7 over 4. We'll do the vertical asymptotes next. So I have x minus 4 equals 0. Solve for x. X equals positive 4. Notice that's where the graph, or the asymptote, is on the graph. Horizontal asymptote. I have 1 over a really big number minus 4 plus 2. The really big number minus 4 basically is 0, so I have y equals 2 left over. This is your horizontal asymptote, which makes sense because on the graph I moved it up by 2. Domain is related to the vertical asymptote, so I have negative infinity to 4 and 4 to positive infinity. The range is related to the horizontal asymptote, so I have negative infinity to 2 and 2 to positive infinity. There we go. Moving right along. Next, an oldie but goldie. These are solved by factorings or just factor. Let's see. Yeah, solved by factorings. Okay. So it says solve the equation using any method. Okay. This is kind of a tricky question, only because people want to multiply it out. It's already been factored. Take each individual factor, set it equal to 0. Already, the hard work's been done for you. I divide both sides by 4 over 3. This might seem hard, but 0 divided by anything is just 0. Square root both sides, I'm going to get x equals 0. That's my first answer. Next one, I'm going to subtract 3 and divide by 2. This is my second answer. The last one, I'm going to add 5. This is my third answer. Just solved it. That's it. Here, I have this big equation. What I want to do is I want to get everything on the one side. So I want to subtract the 8x and the 12. Now, these cannot be combined with the other two terms because they're not like terms. So I'm going to get 2x to the third plus 3x squared minus 8x minus 12. And then that equals 0. Okay. Now what I have is I have 4 terms. None of them are like terms, but what I can do is do factor by grouping. I group the first two and the last two. Out of the first set of parentheses, I can take out an x squared. I'm left with 2x plus 3. Out of the second set of parentheses, I can take out a negative 4 and be left with x, 2x plus 3. I needed to take out a negative to change the signs in the set of parentheses. So I'm going to take the stuff on the outside, the x squared minus 4, and the stuff on the inside to make almost my answer. The reason I say almost is because this, which you probably should have seen in one of the other problems above with the solving rational equations, is a difference of 2 squares. So I can factor that again. So I have x plus 2, x minus 2, and then the 2x plus 3 is left over. These are the 3 factors that make up the polynomial above. All right. Oh, sorry. I forgot something. Now I have to solve them each. So I have x plus 2 equals 0, x minus 2 equals 0, and 2x plus 3 equals 0. So x is equal to negative 2 positive 2 and negative 3 over 2. Yeah, that's ugly. There we go. Sorry, I almost forgot to solve them. All right. Moving right along. All right, in this case, you don't add 32x to the other side. You should realize that these two terms have something in common. They have a 2 and an x. If you take out 2x out of both things, you're left with x squared minus 16. And that equals 0. Now, kind of like the last problem, I find the difference of two squares. X squared minus 16. So I have 2x still left over. I have x plus 4 and x minus 4. I set each one of these three factors equal to 0. 2x equals 0. X plus 4 equals 0. X minus 4 equals 0. And I solve them all for x. X will equal 0, negative 4, and positive 4. All right. All right. Number 17. All right. In this case, what we're going to do is I have to get all the stuff on one side of the equation. I'm going to add 3x to the third to the left. All right, that can be combined with any of the other terms, so I'm just going to rewrite it out. So 3x to the third goes first because it has the biggest exponent. Minus 27x squared plus 60x equals 0. Kind of like with the last problem, we should recognize that you can take stuff out of this. We can take out a 3 and an x out of all three terms. If I do that, I'll be left with x squared minus 9x plus 20. All right, now I can factor what's inside the parentheses. I'm going to leave the 3x on the outside here. Two numbers that multiply to be positive 20 but add up to be negative 9 would be negative 5 and negative 4. And now I can take my three factors, set them equal to 0, and solve for x. All right, two types of problems left. We got the work problems and the total and average cost problems. So working alone, Adam can harvest a field in 16 hours. So we have Adam. Then Dan can harvest the same field in 13 hours. We have Dan. How long would it take them if they work together? And we have together. So we have a harvest and we have time. So Adam can do one harvest in 16 hours. That's an ugly 6. Dan can do the same harvest in 13 hours. I don't know how long it could take them together to do the harvest. So I've seen a lot of students not do the information table. That will help you out. Just organize your information. It helps figure out where everything's supposed to go. So put it down. It doesn't hurt you. Okay. Now these are like the solving rational equations we've already done. Figuring out what's missing. The 16 is missing 13 and x. The 13 is missing 16 and x. And the x is missing 16 and 13, which coincidentally is 208 when you multiply them together. Get rid of the denominators. I have 13x plus 16x equals 208. 13 plus 16 is 29. And divide both sides by 29. So x will equal 7.17. Technically, you should say hours. If you get to that point, I'm happy. Number 19. So we have Aaliyah. She can clean an attic in 10 hours. We have Stefan, who can clean an attic in 15. How long would it take them if they work together? So we have cleaning, and we have hours. So Leah can do one attic in 10 hours. Stefan can do one attic in 15 hours. And together they can do it. I have no idea how long. So we got to figure out what's missing. 10 is missing 15 and x. 15 is missing 10 and x. And x is missing 150. Now you could find a smaller number. Both 10 and 15 go into 30. You could use 30 as the value. You don't multiply the 10 by 3 here. This could be a 3. I'll put a different color. This could be a 3 to get 30, and a 2 to get 30, and a 30 to get 30. All right, or you could just figure out what's missing and do the raw numbers. I'm pretty sure this is on the calculator section, so the bigger numbers don't make a difference. Anyway, continuing on. So now we have what was missing. We can get rid of the bottom. We have 15x plus 10x equals 150. Okay, so now we're going to get 25x equals 150. 150 divided by 25 is going to be 6. 6 hours. All right, next we have Allie, who can make 2 cocoa bombs in 5 minutes. So I'm going to do cocoa in minutes. She can do 2 cocoa bombs in 5 minutes. Cardia can make 4 cocoa bombs in 9 minutes. They work together. How long is it going to take them? But there's a caveat to this. It says if Allie works by herself for 25 minutes and is joined by Cardia, how long will it take them working together to make a total of 144? Okay. Well, if Allie makes 2 cocoa bombs every 5 minutes, how many cocoa bombs will she make after 25 minutes? Well, 5 times 5 is 25, so that gives you that number, but we're going to use that same number, 5 times 2, to give us 10. So in 25 minutes, Allie can make 10 cocoa bombs on her own before Cardia helps her. Okay, so then Cardia's going to help her make only 134 cocoa bombs because Allie's already made 10. I don't know how many minutes it's going to take. Okay. All right. So we're missing 9 and x from the 5. 5 and x from the other, what is her name? Cardia. And we're missing 45 for the total. Get rid of that. So we have 18x plus 20x equals 134 times 45 is 6,030. So combined, you get 38 equals 6030. Divide by 38 on both sides. So x will equal, do my calculator here, 158. There we go. All right, next. We have Mario. Needs twice the time Nikki needs to build a snow fort. So they're building a snow fort, and they are doing it in minutes. So we have Mario is doing 1 snow fort. He needs twice the time Nikki needs. Okay, so we got Nikki, we have together. So Nikki's building a snow fort, together they're building a snow fort. So takes them 45 minutes to build 2. Oh, whoops, hold on. I got a mistake here. If they work together, it takes them 45 minutes to build 2 snow forts. So they're building 2 snow forts in 45 minutes. All right. Mario needs twice the time that Nikki needs to build a snow fort. So Mario's time is based off of Nikki's. So Nikki's time is, we have no idea. We do know that Mario's time is 2 times as many as Nikki's. So that means we're going to do 2x for that. All right. So now what are we missing? So we have an x. We don't need another one. And we're missing a 45. The second one, we have an x, so we don't need another one. But we're missing 2 in 45, which is 90. The last one, we have a 45. We're missing a 2 and an x. So we have 45, because we can do the bottoms, plus 90 equals 4x. So 45 plus 90 is 135 equals 4x. Divided by 4 on both sides. And x will equal, let's see, 33.75. There we go. Oh, hold on. That's not the answer. My apologies. Let's go back. There we go. So the question, this is why it's not the answer. The question is, how long would it take Mario working alone to build one snow fort? Well, Mario's time is 2 times x. So we have to multiply our value there by 2. It's my apologies. I wasn't paying attention. So Mario, his time would be 67.5. And that's the answer. Because the x value there is for Nikki. All right. Sorry about that. A little confusion. I think we're good to go now. All right. Number 22. Chance the Rapper wants to invest his money into a stylist business. He charges a one-time setup fee of $30 per order and then $1.50 per stylus. Determine the total cost if styluses are sold. If 50 styluses are sold. And what is the average cost per stylus? So there's actually 2 questions here. The total cost and the average cost. So we are selling styluses for $1.50. We're selling 50 of them. And there's a $30 one-time charge. So this is the total cost. So if we do this on our calculator, 1.5 times 50 plus 30 gives us $105. So the total cost is $105. Now to do the average, we're going to take that total, 105, divided by how many styluses we're selling, 50. Which gives us an average of $2.10. That's it. All right. Now we will run a write our equation to represent the total cost if X number of styluses are sold. So we're going to do the same part that we just did right here. We're going to put down the cost. So C of X is equal to 1.5 times X instead of 50 plus 30. That is the total cost. Okay. Part C, write an equation to represent the average cost. Well, it's the same idea. We're going to take the total cost equation. This time it's going to be A of X, good for average. Take the total cost equation and divide it by how many styluses we are selling, which is X. Okay, if a customer has $150 to buy styluses, how many styluses could they buy? So if that's the total cost, we're going to put that 150 in front of our total cost equation. And then solve for X. So 150 minus 30 is 120. 120 divided by 1.5. X will equal 80 styluses. And on the other side, the customer wants the average price per stylus to be 180. How many styluses should the customer order? We're going to put the 180 into the equation above, under the average. So we get 1.8. We can put 0 if you wanted. Equals 1.5 times X plus 30, all divided by X. Now to solve this, what we're going to do is we're going to multiply by the X on the bottom of the fraction to both sides. What happens is that cancels out this side and this side. So now we have 1.8x equals 1.5x plus 30. Subtract 1.5 from both sides. 1.8 minus 1.5 should be 0.3. We're going to divide 30 by 0.3. So X will equal 100. So you have to order 100 styluses for it to average $1.80. All right, Miss Marlega is planning her wedding reception at a banquet hall. The hall has a fixed charge of $300 plus 85, what is that, 85? I can't read. $35 per person. Okay. So we want to, again, determine the total cost and then the average cost if 95 people attend. So we have $35 per person. There's 95 people, plus $300 for the cost of the hall. So we have 35 times 95 plus 300 gives us $3,625. To find the average cost per person, we're going to take that total and divide it by how many people are coming, which is 95. So the average cost is going to be 38.16. So $30.16. All right. We're going to write an equation to represent the total cost. So we're going to write this equation with an x instead of a 95. We're going to put C of x for cost is equal to 35 times x plus 300. That's it. To represent the average cost, we're going to do A of x. We're going to take the total cost equation. We're going to divide it by the total number of people coming, which we don't know, so we're going to write it as x. It says, if Miss Marlega wants the average price per person to be $37.50, how many people should attend the wedding reception? So we want the average price. So we're going to take the average equation, set it equal to $37.50. All right, like before, we're going to multiply both sides by x to get the x off the bottom of our fraction. So this goes away and this goes away. So I have 37.5x equals 35x plus 300. I'm going to subtract 35 from both sides. So 37.5 minus 35 is 2.5. And divide 300 by 2.5. So I get 120. So there needs to be 120 people going to a wedding to average $37.50. And ladies and gentlemen, that is it. Please make sure you're reviewing for the test so you can do well on it and be successful in class. Good luck.